So my name is James Brown, and I'm the Director of Customer Engineering, and my team works with top customers to help them use more Google Cloud. One of those customers is Snap. And so today, I'm really excited to hear from this panel about how Snap went from running a monolith on App Engine to scaling to over 400 million daily active users on GKE with microservices. We're going to dive into the strategy that they used, talk about the engineering decisions, and ultimately help you understand the path that they went through. I also want to highlight the very close collaboration that we have between the customer and Google Engineering. It's also facilitated by Customer Engineering, the team that I lead. And so with that, what I want to do is hand this over to Shub, Shrivastava, one of the engineers on my team, to walk us through a fireside chat. Thank you.
Thank you, James. Yeah, I think it's working now. Hello, everyone. So today is an exciting first day of Google Cloud Next. And I know we are towards the end of the first day. So thank you so much for sticking around and joining us. Thank you so much for your time. And like James said, today we will be talking about Snap's journey from monolith into microservices and how they build this robust infrastructure platform on their mesh, and which is actually powered by GKE. So on our panel today, we have Pere, who's a software engineer at Snapchat, and Drew Bradstock, who's our Senior Director, PM, Cloud Runtimes here at Google Cloud. So do you guys want to quickly introduce yourself, and then we can,
yeah, sure. My name is Pere. I've been working at Snap for a little over 6 years, so on our deployment tooling, and then for the last number of years on our internal service mesh and deployment tooling.
Hi everyone, I'm Drew Bradstock. I run product for container runtimes. That includes GKE, includes serverless, includes App Engine as well. And Snap has been a long-time partner, so every single time the app doesn't work on my phone, I panic for a little bit and worry if it's something to do with our product. So.
Thank you both for joining our panel. All right, so let me start by asking you guys, with a show of hands, how many of you here are platform engineers or infrastructure engineers, or kind of building a platform team at your organization? All right, we've got quite a few. How many of you are application developers who kind of use these platform as a service in your organization? Awesome. So we have a good mix of people from both the teams, so that's pretty interesting. So our session today will be focused on how Snap exactly does this. They have built their mesh layer, which provides this secure abstraction, a very fast-paced, developer-friendly abstraction on their compute for their end customers. So when I say end customer for Snapchat, that's their application teams, the developers who use the infrastructure platform as a service, as a product. Also, if you're in the journey of building your infrastructure platform, we will be also talking about the best practices, what worked for Snap, what didn't work for Snap, infrastructure design pattern, to run such a massive, huge application, which is now supporting more than 400 million daily active user. So we are really excited about our talk. And with that, Pere, let me ask you, can you tell us a little bit about what Snapchat is and your role as an infrastructure engineer at Snapchat?
Right, yeah, so as you touched on, Snapchat or Snap Inc. is mostly known for Snapchat. You might know it for the crazy filters or funny things and memes on it. Currently, in our latest, currently we have a 400 million DAU, 800 million monthly active users. And the app is very popular with young adults, of course. We reach 75% of 13 to 34. So it's very popular. People get really upset when it goes down. I've gotten DMs on like other social media. People are like, hey, what happened? Snapchat's down. You get that more often than you would think, actually.
Yeah, I mean, I personally love Snapchat filters. Sometimes I feel all you need is some puppy dog ears and some crown tiara to, authentically express yourself. All right, so we know Snapchat was born on Google Cloud, and that was way back in like 2011, right? So at that time, what was Snap's idea behind choosing GCP as your cloud provider? And also, when you were building this monolith on App Engine on GCP, what were some of the key challenges that you faced, and how did you overcome and went into this architectural shift of service-oriented architecture?
Yeah, sure. So when I came to Snap in 2017, we kind of had one big monolith, right? Like it was one API that was deployed, and it was basically the entire app ran on it. We started off on App Engine. We're kind of like the App Engine marquee customer, I guess. And interestingly, Snap and Google Cloud kind of got born at the same time, right? They kind of grew together. So that's why we've always had a very close relationship with the tooling, with the engineers, because we kind of grew together as, Google Cloud grew their product line and we grew our user base together. App Engine was really great for a lot of things, honestly. There's still things that developers are like, why can't it be like App Engine? So yeah, like there's still a lot of good abstractions there, and that's what the service mesh was built to solve, like traffic splitting, things like that. And the move to SOA was really predicated by a number of factors, right? Like we had developers that are like, well, we can't ship changes fast enough to the user. We can't build a feature because there's this very, very large code base that takes a very large build cycle, and it deploys quite slow, actually. So when I got to Snap, we could only roll maybe 10 changes a day was a really good day. And then unfortunately, if you broke the repo, everybody was like on hip chat back then, like what'd you do? You broke the repo. And so we really need to move to a place where those teams could move fast and not break other teams. And that's kind of how the SOA was born. Like we're becoming a global app. Google is, of course, a global company. They have global regions, and we needed to obviously branch out, right? And all the things just kind of worked, right? The IAM on Google, the service account identities, all the things that we were used to kind of worked on GKE, right? So it was a natural choice, and that's kind of how we went down that line.
That's awesome. That's such a fascinating story. Before we dive more into GKE and Mesh, I have this question about, standard platform engineering or building a platform. So I know your end customers are the application team and developers, and they're very two different governing principles, almost like, like your application developers want the flexibility, and they want the autonomy. They want to use all the new tools versus you want to standardize your platform. You want to have those guardrail security policy. So how do you navigate between these two different governing principles when you're designing your infrastructure platform?
Yeah, that's a great question. So yeah, kind of one of the interesting cultural things, I think, that we have at the company, and it's always there and it still is like a culture of tools, not rules. Like we don't predicate to our customers, being the app developers, what they can use. Like whatever it is they want to use to solve the problem for the business is acceptable within reason, of course, right? And so being able to utilize like new features like the ones being announced today, right? Like if we didn't allow people to use these new features and you had to get through this like bunch of red tape to just make a new service or make use of a new thing, it slows down developers, right? But you have to always balance, right, the amount of creativity, I'll call it, that can be done, right? And so we kind of solved that with the service mesh by like one of the hardest points of creativity is like authentication, authorization, and network design, right? No one wants to do that. No app developer is really wanting to do that. So that's kind of how we started. And then from there, it kind of branched out of like, hey, well, let's build a deployment tooling around this too, right? Let's build a metrics testing and a canarying system. Like let's build in like traffic shaping features. Like we listen to our customers and they say like, this is a great tool, but like I have this thing I want to do. And then we kind of collaborate with teams and be like, hey, we're launching this new feature and we need this like crazy amount of traffic, or we need a new feature, or the service mesh doesn't quite work. We really work to like be kind of like a startup inside of a startup kind of, right? Where we have to basically be like a PM. You have to be like, hey, what is it that is not working? What is working? And we kind of are held accountable to that. Like by like making sure our users are happy, right? And that's kind of how we measure the success, is like how many people can use this thing? Are people happy with it? And then, where are we at in the industry? Are we staying ahead of things? Are we behind things? Like whenever there's an incident or some mistake happens, we can be like, hey, how do we leverage the system to make this better and make this not happen again? And that's kind of how we think about it as a platform.
Yep. I love the quote, the culture of tools, not rules. And also the fact that as an infra team, you actually act as a PMs for your product. Like your infrastructure layer is essentially a product. Before I move on to the next question, I do have a follow-up for you, Pere. So we know that for the infrastructure team, there's also a very big mindset for Snap is ensuring developer productivity. So how do you do that? And especially if you want to talk a little bit about your UX layer and anything that you wanted to tell us about how do you ensure developer productivity and velocity?
Yeah, that's a great question. So one of the big things that we focused on a few years back, and it's a really big thing now, is sort of your developer portal, right? That's a lot of companies are doing this, like Backstage, that sort of thing, right? Where developers need to go to one place to do everything. And so kind of the success of the service mesh, right? It kind of made it that everyone was going that UI all the time because they're like, oh, I got to check on my metrics or do a new service and I'm going to go to this UI. And then over time, we're like, hey, let's just build all the stuff in the UI, right? And so we kind of use that as a platform and we keep expanding it year by year what it can do. And so that's kind of one of the things we think about is what we actually we send surveys at the company as well to our developers. We'd be like, hey, give us feedback, 1 to 5 on is the UX good? Do I know how to deploy changes? Did I have incidents because of the bad UX? And give us feedback. And then we kind of go back, PMing again, right? We kind of go back and I'm like, all the time I'll DM someone. I was like, oh, was that my tool that did that? Was that a bad thing that we did? And then yeah, if we just change this a little bit and tweak it, my team would love it. And then that's a really powerful tool to be able to reach out to your users and give them what they want, essentially.
Yeah, that's pretty incredible. So Drew, I want to know from your perspective, with infrastructure engineering and you working with so many customers globally, different shapes and sizes, what is the key theme or the key value prop that you see for customers that prompts them to use technology like Kubernetes or GKE in general?
I think it's very similar to what Pere spoke about. It's the ability for teams to be able to offer the platform that meets the needs of exactly what your business is. I think Snap is very unique. You've been very customer-centric and actually treated all your developers as actual customers, but that's where GK has really excelled. It's being able to have one platform across anything, be it, and this is the obligatory AI reference, it has to come up at least once in the session, but it's having one platform across everything, but still the ability to customize it. Quick question for the audience, because the tools, or the tools not rules, was actually shocking to me. I find a lot of people are leaning towards rules not tools, so quick show of hands, who is more, if you had to define your company, are you rules not tools? Show of hands. Or tools not rules? Oh, I saw some hands, so, okay, that's better. Let's try that again. Rules, tools, a little bit of both, and it's a little chaotic. Okay, the hands that didn't go up, I'm assuming that. But I think on the GK side, it's a flexibility. It's being able to work tightly with customers to allow them, like Snap, to be able to make sure the platform meets exactly their needs. And that flexibility is really what makes us shine.
Yeah, then to add to that, in the old App Engine days, right? We only had, it's kind of crazy. The whole app ran on App Engine's standard instances. With people were not familiar back then, they had a very big limitation on resources, right? They had, I think, 20 gigs of disk space. I think there was only 1 gigabyte of memory. And so everything ran on that. And I can't imagine running AI stuff and all that we have today. And some of the caches we have and things we built to improve performance would be impossible, right? If we didn't have these really flexible systems like GKE.
But a lot of the legacy code is still running out there. It's amazing when I took over serverless how much App Engine is actually out there because it just works. And it's a pretty fast developer way of really approaching something that's going to last for a while. Most of that's moved to Cloud Run at this point, though.
Yep. Actually, similar question for you, Pere. So now you have these interdependent services with clear contract of communication between one another. They are independently deployed, also known as service mesh or microservices. What was your thought process behind choosing GKE as your compute of choice and powering your entire mesh with that?
Yeah, that's, it was just kind of a, I don't want to say there's any easy choices, but that was certainly one of the easiest ones we did. Because obviously, like I mentioned earlier, we were already heavily invested in App Engine and still are to some degree, right? And we just had everything we kind of needed there. The developers were very familiar with the tools, right? Like you had good documentation, there was good, like GKE at the time had a lot more better features around auto scaling and things like that, like the compute that it could use. And frankly, the tool just worked, right? And that was what was most important, is like, oh, well, if I need to migrate this thing from App Engine over to this thing over here, they could behave very similarly. Like they could have a similar network, they could have, everything was just kind of there, right? And our developers really love the Google console as well. So like the UI of Google Cloud, people were very familiar with it. And then when we didn't have our own tools, right, we had to use that UI, and it was very important to have that, to be able to debug, get used to things, and have our developers really gain a familiarity with the new tooling was really paramount. So yeah, there's a lot of factors really.
That's awesome. Yeah, that's good to hear. I do wanted to ask from you, Drew. We have this unique partnership and relationship with Snap. Anything that you would like to talk about our partnership with Snap?
Yeah, I think the number one thing is that Snap's pushed us literally from the very beginning of App Engine on to GK. Everything didn't go smoothly. There's a lot of patience between it, but I think it was taking a look at how fast Snap was growing and their scale needs and even their cost needs. Like, how do we make sure that we had to change the products, but that end-to-end conversation. And then on the Kubernetes side, making sure we gave back to the community, because Snap didn't want to be isolated down to one platform. They wanted choice and flexibility. So a lot of the work we did, we then gave back to the community, in addition to a lot of the more advanced auto scaling we did. But I think it was, and this is what I encourage all of you as you work with Google, it's push us and really make sure we know what's not working, and then we can make the products a lot better. I think App Engine is a great example of that, where GK now, we wouldn't be where it is without the feedback, even now, in the past week from Snap on a lot of the AI workloads in other areas.
Yep. I just have a quick thought on that, and I want to add, we are really grateful for having a customer like Snapchat as our co-innovator and our design partner. They always lead the way, they always push us and towards some cutting-edge innovation. So that's the the symbiotic relationship that we have with Snap. We would definitely touch on some of the co-innovation stories probably later down our discussion. But Pere, do you have any thoughts about co-innovation? How's your experience so far? Any feedback?
Yeah, like we definitely, it's an interesting experience working at Snap. So like, I've been the small startup where like I couldn't get anyone on support for like 2 days. I'm like, what's going on? My thing is down. And then here it's kind of like I have a little bit more leeway there. But really what's been great is like, working with, Google's commitment to open source, right? Like Kubernetes is open source. Like a lot of the things we do benefit the greater community, and that's kind of how I see things. Like we try to use open source things, like our service mesh is built on open source things, and it's very similar to like Cloud Run. Actually, is kind of a similar. If you want to use one off the shelf, that's pretty similar to what we have. And Cloud Run is kind of it, right? And so one of the great things is like when the Cloud Run team came and talked to us when they were talking about this product, we got to actually give feedback and say like, oh, this is what we're doing, and then they were able to build that. I think parts of that to their product, and it's been really important over, especially now with the crazy innovation around ML, the crazy needs around ML. I'm sure he gets a lot of meetings around that.
A few.
Just a few, right?
Yeah.
It's just really great to have that partnership, and we really value Google as a partner. Like they're kind of like family in a way, right? Like they're always at our meetings and make sure we're doing well. And we try to give back by making sure everything we do is something that's useful for other people, right? We try to make sure everything is really useful that we request, and like it's intentional. So yeah, that's
so wonderful to hear. Thank you, Pere. So with platform engineering, I have read somewhere that it's like playing a game of Jenga, where you're constantly thinking about your next move, and one wrong piece and your entire production system can come down crashing. So I want you to unpack a little bit about that in terms of challenges that you have faced so far, especially running such massive scale of cluster on GKE. So any challenges, any problems, anything that didn't work for you, if you want to talk a little bit about that.
Yeah, that's a great leeway. Yeah, the Jenga thing is always feeling like it's about to fall over. So like, when you've been in this industry for a long time doing platforms, and you were getting into it, and people are getting into it for the first time, there's so many things that can go wrong. It's like what can go wrong will go wrong, right? So you always have to worry that you never know when something's going to happen, and so we have to design resilient systems around that, right? We have to be like, oh, what happens if we lose a zone, right? Like, what happens if we can't deploy because maybe there's an issue with authentication? We really have to think about those pieces, and that's kind of how we thought about building our platform. We tried to make sure all the pieces hook together really nicely, but they don't predicate that they're all together working, right? Graceful degradation of the system is important. If we lose GitHub, can we still deploy? Making sure that that's possible, right? Every little piece you have to think about, because it will go wrong over time. And I think one of the biggest learnings we've had in one of the projects we've been working on is our managed mesh concept, which is our customers basically own the Kubernetes cluster. Each cluster was a service essentially, and those teams were on the hook for basically managing that cluster for years. And our developers hated that. There was a couple that loved it. They're like, don't take it away, I love doing this. But most of them didn't like it. So that's what we've been working on in workload identity. I think there's a talk after this with some of my coworkers in security around workload identity. I think it's the next ballroom over. And we did a lot of work around that. We're like, hey, let's not have a cluster anymore. Let's just have some compute that they want, right? They specify the deployment, and then we kind of shift and put them into the right spot. And then they don't have to deal with add-ons or upgrades or all that stuff that's kind of wasting their time to a degree. And so we think about taking on the pain as our customers as a way to innovate. So when it's something that's painful for me, now I have to get paged if that upgrade fails and it's not them.
Sorry.
Yeah. we have to, or we broke someone when we upgrade, right? We have to think about how could we automate this so that way it's not a pain point for me anymore. And that's a big part of how we think about leverage as something you can use to improve things, right? If you don't feel the pain, you won't improve it. So we always try to get to that point where we feel like things are just kind of running themselves. I wish it was always that easy, but sometimes it does, and then things change, right? And that's kind of how we think about platforms at Snap. We try to think about it how can this thing remove the human element as much as possible with allowing the human element to operate on it, right? They have the tools they need, but there's safety guards in place so that way they can experiment safely.
Yep. Want to hear your perspective on this, Drew. With so many customers now adopting GKE, and always there are going to be challenges and issues, and it's always such an evolving landscape. So how does GKE keep up with our customer needs and making sure we are giving them the scalability, reliability, cost efficiency when they're building these platforms on GKE?
I think there's a couple of main things. One is, how do you high complexity for developers, similar to what Pere spoke about Snap. The more you can make them not think about it, that works. But even from chatting with customers this week, the big challenge is you get a few people using it, and then how do you get everyone using your platform? And I think that's the customer-centric view that Snap brings that we're trying to do on the GKE side. How do we make more managed such that the app developers never need to worry about it? And also platform teams need to worry less about it and just worry about customizing it for your team. The second is cost. The reality is, both on the AI side and just everything we do across batch, training, analytics, serving, all of us are under pressure to reduce cost. And that's been a big focus for GK, both on the human side of this, but also just the actual resources you're using. And the teams, I'm still finding a lot of teams aren't spending enough on that. It's very reactive when, oh, there's budget cuts, let's do it then, versus constantly trying to really scale back to only what you need. And that's where GK helps a lot. And the last is probably efficiency. AI is changing things. but also the way people view efficiency. It's not just how many VMs I'm using. It's like, what does it cost the business to get value back? And I met with a great client today who was trying to shift that way and speak the platform team to their end customers, like Pere said, of what matters to them. And looking at it from that way is really elevating the platform teams a lot, and that's what we're trying to help out on.
Yep. All right, so before we move into more technical discussion about managed mesh, I remember reading somewhere on one of the Snap articles about how the end goal for the infrastructure team is, even if there is an intern who's trying to stand up or run a productionized workload or a service, they should be able to do it by lunchtime. So just wanted to know, Pere, like, what are your thoughts on that, and how do you achieve that?
Yeah, like that was a challenge from one of our big bosses. Was like, hey, I want to go get a coffee and then have a service ready when I get back, right? That was kind of like our North Star that we took with the tool. And we were very, very far from that North Star when we started. Like, so it's.
Was it a tall coffee or venti coffee?
I was like, is it a cold brew? Like, basically, I think cold brew would have worked. Yeah. It took us like over a day and probably 4 engineers to onboard the service when we first started. Like, we had to provision the clusters. Someone ran some Terraform script to like join the GPCs, and like it was a lot. So we were like, okay, so what can we improve here? So that's where we made our cloud provisioning systems, and we're like, okay, let's make an API for this, and we made an automation for that, and then piece by piece you pick out the things that are causing problems, right? You can't solve them all at once, it's too overwhelming. So we just solved piece by piece, and then once we had the service mesh so that it could provision the networking and then all the routing rules are ready to go, then we're like, okay, what else is broken in? So from there we were like, okay, how do we get the code working, right? And then from code to container, right? Like that life cycle is what we focused on next. And so then we built like a bootstrap tool. I'm sure many companies have something similar, some developer CLI or something like that. And so that's kind of how we took that approach, is like, all right, you clone this repo, then you have this bootstrap tool, it tells you if you want Go or Java, and then it says like, is this a production service? Is it a tiered? We have like service tiers, right? Like for how important they are, that allows us to provision maybe some more expensive resources or like block things that you shouldn't be doing. And that's kind of how it works today. You just kind of hit this little CLI, and then it asks you a few questions about your service, and then it spins up. And now that we've had managed mesh, that was the final piece, because creating the Kubernetes cluster took quite a while, like just a minimum of like, 10 minutes, I think. So that was when we're like, hey, if we don't create the cluster anymore, you just write the bootstrap tool and then just deploy, right? And so that was a big improvement that we worked on. And yeah, so as long as you can do that even at a smaller company, right? Like if you just use shared clusters, like workload identity, you can kind of get the same experience. But that's how we think about, like going back to the tools, not rules, right? Like you don't have to do it that way. Some teams have their own provisioning scripts because their org operates in a certain way. But for most users, the common denominator, it's totally how we think about things.
Okay, yeah. So when you're talking about working with these different teams, right, different applications, different workloads, and all of these workloads have different necessity when it comes to the memory, the CPU, storage, and whatnot. So how do you standardize? When you work with a bunch of these teams, how do you standardize and make sure your end customers, that is developers, get what they need to run these workloads successfully?
Yeah, that's actually a big point of what we've been working on this quarter. And so basically, like the simplest thing that we do, right, is CPU and memory, right? Like those are quite easy to fit and understand and how they work. That's kind of how users specify their needs for now. But obviously with ML, other things, there's GPUs, there's SSDs, there's different classes of SSDs sometimes that they need. There's, the second, different like attached volumes perhaps that they need. And so these things are quite tricky. So that's what we're working on getting really like knocked down. But the way we think about standardization is with the Managed Mesh project, right, is like we say you can choose like a CPU architecture or maybe an exact instance type, but we try to frown that away. Like if you choose an instance family explicitly, that doesn't really give us the chance to migrate you to something that might be better. So we try to like think about things as like a commonality across whatever the compute resource is, like things that are common, like I need a GPU or a CPU, I need an AMD or I need an Intel, those types of things that are quite important. And that's how we schedule people. And then for standardization, the way we're thinking about this is that, like, you know, every conference, right, there's a new instance type, right? And it's a new hotness, like you have to have it. And so what we're doing now is we're auto-migrating people. So like when a new instance type becomes available or instance family we find like is more cost effective, or a size of instance that's even better, right? Because we can adjust the memory CPU. That's how we migrate people across. So you just take, you know, in Google and GKE, it's not that hard to migrate a node pool, right? So that's kind of how we think about things, of like, here's like our more preferred instance types. There's some teams that might have like reservations, or maybe they're using spot instances or something different. But that's how we think about kind of the compute. Like, it's kind of like, you know, just don't worry about what the compute it's on. If there's an issue, then, you know, we can resolve it with placement. But most of the 99% of the time, right, like you can move services safely between instance types. And that's kind of how we model it at Snap.
Yeah, that sounds incredible. Before we move forward on this topic, Drew, I did want to talk about one of the co-innovation story with Snap. And that is actually solving the problem that Pere mentioned in terms of having different workloads, having different requirements for VM families, CPU types, memory. So when we saw these problems, and that was really required for our customer to have like cost management as well as obtainability and operational efficiency, the solution that we have right now is the GKE compute class. And I would love to hear from you in terms of how that's going to solve the problem and your thoughts on that.
Yeah, and I have to thank Snap for this. This is something where they came to us and said, look, we want to be able to cascade down from cheaper resources, depending on the service, obviously, down to more expensive or harder to find resources. So if they wanted to use Spot to start out, and once Spot was out, how they cascade down to one type of compute and then down to another, but in a flexible way that defined exactly what Snap wanted to do. And we thought, okay, first, let's make sure what we're building actually gives Snap what they want. That cascadability based on workload to exactly what they wanted. So we built that up and did a lot of back and forth. So it wasn't just a Google thing. It was really matching what they needed. We took that work and actually looked at, well, how do we automate it such that you don't have to have the platform team constantly adjusting this, but instead, with compute classes as part of Autopilot, how do we just have that cascade? You define it, we take care of everything. So it's all automated, but you can go from cheaper or more expensive, depending what you want. Let's say you've got some reserve instances you want to burn through, right? Or you want Spot last, because you're crazy. But whatever combination you want based on what you need to have, this can all be defined, and then it just let it loose. And this way, to Pere's point, it hides the complexity from app devs. You can adjust it easily under the covers, but really meets what you want from a cost or resource capabilities. GPUs, this is great. GPUs, there are other options, right? Especially as we get to inference, you may want to be able to use just certain different compute classes that are much more cost efficient, but this will allow Snap to be able to hide that from the developers and the platform team to adjust at will based on how they experiment. And I do completely agree with Pere. Locking your developers in and not into something specific creates a nightmare for the platform team. I like the way they've abstracted away and experiment a lot. Not enough platform teams play around with things and see what works for them, because we're so locked into just trying to get the platform going. Taking a step back and doing more like Snap with that level of experimentation and then changing things without influencing or impacting developers is so key to having a good platform.
Thank you for that information. And this feature is in preview, but if anyone...
Reach out.
Yep. Anyone has any question about it, we'll be more than happy to talk more about it after the session. All right, so one thing with platform engineering and infrastructure engineering, Pere, is the fact that it is not just compute, right? It's a complete ecosystem. So it comes with its own set of capabilities like APIs, services, troubleshooting documents, support documents, so that your end customers can adopt your mesh or your infra layer. So how do you ensure that at Snap so that they have good experience at the end of the day?
Yeah, like, so the way we think about it is there's like a number of different tools that we kind of own and provide to our customers, and they're kind of just like sort of the normal building blocks of a service, right? And so some of those, obviously, there's the service mesh, which is your networking, right? Then, you know, API gateways, which is how things get in from the internet, right? And then we provide other things, though, on the developer side, too, right? So build tooling, we have like a build service that like builds containers for people. We have the Bootstrap tool, which I talked a little earlier, where it's like how they get all their configs in place. And then we have a number of different systems that all kind of like play nice together to deliver a good experience. So like, you know, we do use config as code, of course, right? So like your deployments and stuff are defined in config as code. That's kind of how we think about that problem. And then we also have other settings you can set there too, like for different things that you can like kind of hook your dashboards in with your deployments, and then from that we can infer some of the health rules, and then that's how we do canaries. So we try to remove as much config from the user as possible. That's kind of how we think about less config is a better experience usually, almost always. So we try to think about like what's the least amount of things we need from our customers to give them the functionality they want, right? Like if we expose a config, are we going to regret that config like 2 years down the line? Yeah. We're like, oh boy, we shouldn't have ever let them set that. So that's how we take a really hard stance on like if we add a new config, we have to have a really good reason for it. And I think that's been quite successful because it's kind of caused pushback where like the customer needs this config, and they're like, well, let's take a step back, and from a platform perspective, what better way could we solve this, right? And that's how we improve the developer experience overall, because now they're like, whoa, I didn't have to actually specify that config. How did it work? And it's like, well, we just kind of know because it's actually already, the data we need is already available somewhere. And hooking all these things together, again, the switchboards, the developer portal, I think is a very important tool to have it at a medium to large or even small company, really, to have people synchronize on this tool and be like, hey, you need to collaborate. Like, look at, here's the page, like, here's the bad deployment. Like, you're not sending like deployment logs from a Jenkins script. You're looking at it and saying like, hey, let's go jump into the logs or the metrics. And that's been quite successful, I think, is driving a lot of things through the UI and then also some parts of config as code.
Yeah.
Just one thing I'd add, it's incredibly rare, unfortunately, that platform teams push dashboards out to the developers and give them enough information. Developers want to see this. Giving them information in their service, not all the information, I'm not saying that, but I like that because it does get buy-in from them, allows them to understand things. It cuts down the burden on the platform team a lot, and gets them using the platform and checking it more often, and then they can course correct on their own.
Yeah. I'm always so fascinated by switchboard.
Yeah.
Anything else you want to talk about it? Like, how does it ensure like you have a reliable CI/CD pipeline? What does that entails, and anything you wanted to add about switchboard?
Yeah, so basically one of the things we try to put in there, right, is like abstracting away Kubernetes. Like it's trying to remove a little bit of Kubernetes from everyone. Like I had a senior developer come to me. He's like, "Why do I need?"
You're making me sad.
Yeah, he's like, "Why do I need to learn this, Pere? Why did I need to learn this for this task, right?" And so we try to use the UI and then some of these abstractions to sort of like hide it a little bit. Obviously, there's cases where you need to debug and like maybe you need to actually, the platform teams need to look at that piece, right? But we really ensure that like there's a certain pipeline shape that we kind of predicate. Like it's kind of a rule, but it doesn't feel like a rule, right? Like it's like, oh, I just got this deployment and there's a canary and then my integration test runs and then like it checks if there's a problem in Envoy, right? Like when we have all the standardized metrics are very important, right? So we know exactly where their metrics are just from which service it is, right? So we can look at things like failure rates or latencies, things like that, and then our developers don't need to specify that. So like if you standardize things, you kind of make a rule, but it doesn't feel like a rule. And so that's kind of how we handle the CI/CD pipeline. Like there's some rules in it, like we check for things that could be a bad idea, like a misconfiguration. We catch that at build time, so they can't merge their PR if it was like something we detect that's an invalid state, like they're trying to change a deployment label, like things you can't do. And that's kind of how we kind of hook in. There's like the validation cycle, then there's the delivery cycle, and they kind of play nice together, so that way you get the benefit without a bunch of doubling, configuring multiple different things.
Yep. That sounds so interesting. Well, I cannot let both of you go without asking a question on AI/ML. So I have to ask you a question on AI/ML. So Pere, I'll start with you. With AI/ML disrupting the cloud infrastructure landscape right now, what is your vision on adopting or kind of integrating the ML platform into the infra layer? And how do you see that standardization coming into fruition and for developer productivity and for your ML workloads?
Yeah, I definitely spent no time on this last quarter. Yeah, it's a big problem. I haven't really seen a shift in the way services are deployed or used in quite some time like this, where like you have these inference platforms where the models are so big they're split amongst partitions, and like dealing with how things traffic split, like ML developers behave and operate a little bit differently than a back-end developer. Like their needs are different. Like they want to experiment on things. They're maybe a researcher. And so when you provide tools to them that make sense to you as a back-end developer, they don't make sense to them. They're like, how do I get my Python thing to work? And you're like, oh, okay, well, so that's one thing that we're working on is like, how do we make sure all their tools interoperate with Switchboard and Switchboard exposes the right things for them? And of course, the biggest challenge of the platform team with that is like, the need for GPUs, the need for like really tuned applications, right? Like it kind of breaks the cattle, not horses sort of analogy, where like everything is a horse in the AI stack, like any small...
A racehorse.
Yeah, like I was talking to this with one of our heads of our AI platform at lunch today, and I was just like, yeah, it's like any small change can cause a huge regression, right? And so providing experimentation tools, like benchmarking is very important on ML workloads, and it's kind of important on backend, but not really, right? You deploy and it works, it's fine, but ML stuff, you really have to benchmark, make sure it's working, and that's where we'll be investing a lot of time in and over the next few quarters.
Definitely makes sense. And Drew, what's your vision on?
I think it's fun. Like, people forget, they see it as a challenge. This is actually from a platform point of view. We've all invested in our platforms. You've all invested in your platforms. It's leveraging the hard work you've already done. Yes, inference, to Pere's point, is really different from serving. It's also really similar to serving. So I think too many people are looking to throw out all the hard work they've already done. With a solid platform, the skills and experiments you've already built up. Same with training. Training is batch on steroids, legal steroids, but I mean, it's different, but you really can use more of what you've got. I think the difference, to Pere's point, is you're gonna have to experiment a lot more. Like it was more, even the platform teams, once you got it there, it was there, right? Switchboard, it was fairly consistent. There is a lot more volatility as you settle in and figure out what works for your models. There needs to be a lot more cardinality and experimentation. I'm seeing Snap do it. That's, I think, the biggest switch, but see this as a challenge and opportunity to try a lot of new tech, but don't throw away what you've got because it'll really help you move faster with what your business wants in this regard.
Awesome, yeah. Before we are almost at time, and before we end our session, any hot takes from both of you on platform engineering, GKE, Mike is all yours, Pere.
Put me on the spot. I just feel like, it's going to be interesting. So I'm excited to see all the new tooling for ML as it gets integrated into Kubernetes. I think that's going to be a very important piece of the tooling, like how everything kind of operates together. I'm excited to see that unfold and all the tooling. I feel like I'm learning everything for the first time again. All these new tools, all these new acronyms. There's a lot of new acronyms I need to learn, so it's a lot, yeah. But it's exciting to see, and it's always exciting to learn.
All right, last thoughts.
I think the platform team will actually become even more important, but it'll be hiding the complexity from people actually using it. It was app developers, there's going to be AI operators, there's going to be AI developers. They don't want to know all the hard work all of us have done. So I think the more you can focus on rapidly hiding it, they really don't need the extra knobs. It's not going to be the expertise. So that's going to be really hard to tell them. Oh, that's my hot take, because they're going to read a million articles, come back from Cloud Next, want to change things. Say no, right? Like, just experiment on your own. I think that's my hot take, and then you can blame me.
Having the blinders.
Yeah.
Focusing.
Yeah.
All right, so that brings us to the end of our session. Thank you so much, Pere and Brad, for your time, and thank you, everybody, for attending our session. And have a great rest of your Google Cloud Next. Thank you. Thanks.
Awesome. Thank you. Thank you.